Yes, I will.
Okay, good afternoon, everyone. Welcome to today's Dapp Learning sharing meeting. We maintain open source Dapp development tutorials on GitHub. We could not only give junior developers a simple list and a executable blockchain Dapp Learning roadmap, but also present advanced developers with a platform for communication and cooperation. Today, we have invited Yu to share about issuing bonds using debond protocol. Hi, Yu. Can you give us a brief introduction about yourself and the debond protocol?
Of course. So basically, I'm Yu. We're based in France, and I was a backend engineer in AXA. So basically, we developed solutions for traditional companies to issue not only bonds, actually it's any kind of financial product on blockchain. And we're aiming for the KYC compliance with also many features that the traditional institutions care for. So basically, for the presentation, I'll be presenting our solutions. So basically, there are two parts. The first one is the debond part, which is a solution for tokenization of any kind of financial instrument. And the second one is what we call the society, which is built-in KYC solutions that I think in the future, when the regulations becomes much more severe, it will be absolutely needed solutions for most of the DeFi project. Yeah, that's basically about myself and about our project. So if you may, I can start the presentation. First, I can start with the ERC 3475, and then I can explain a little bit when we talk about issuing financial instrument like bond, what will be the difficulties and what will be the issues we need to address. So basically, I can start with the presentation of the EIP 3475. And as I mentioned here, it's an interface for tokenized application with abstract on-chain metadata storage. So basically for us, the ERC 3475, it's a way to put all the metadata on-chain and have an abstract way to manage it. So to make it this much more understandable, I have something that I can show you. So basically, I have another presentation. I explain better what is this kind of solution. So basically, ERC20 and other existing token standards, it's like a mobile phone with a physical keyboard. So the idea is that I can seal a mobile phone with a physical keyboard that can shoot perfectly the use cases I'm creating this mobile phone for. And the problem is that if with virtual use cases, let's say, if we are talking about bond, we have some utilities or some functions, especially for the bond. And if you want to use the same standard for other things, it's like if you want to use the same standard for zero coupon bond or for a bond with coupon, with a callable bond, with a non-callable bond, or even with intellectual properties. So if we talk about tokenizations, we need to design a huge keyboard with all the keys on it. And this is not a solution basically to just add some keys to an existing physical keyboard. So basically for us, we developed a solution that allows you to have a touch screen mobile phone. And with the mobile phone, based on the application you are using, the keyboard will have a virtual version that will be casted on your mobile phone. So basically that's why the idea about abstract comes from. So I have a comparison here about our token solutions with other token solutions who are pinned or commonly used to be a representative of financial properties. So I mentioned here ERC20, ERC 721, 155, and 3525, and our. So basically, in practice, so let's say if I'm talking with an engineer working in Ledger. And they will explain to me that currently you have three kinds of token solutions. So the first kind is ERC20, and with that 20, you have several types that I didn't mention here. And with another one, it's called NFT standard. So the 721, 1155, and 3525, they're actually using the same interface. So basically, they are regarded as the same token types. And then you have 3475, which is a little bit different. And I explain where comes to the difference. And I mentioned here with 1, 2, 3, 4, 5, 6, with 6 parameters, what is the difference? So the first, we are talking about fungibilities. And here with the ES20, it's a fungible token. And the 721, of course, is non-fungible. And both 1155, 3525, and 3475, it's what we call semi-fungible. So this is defined by ERC 1155, means that a token both fungible and non-fungible at the same time. And afterwards, we talk about metadata, which is in the case of financial good. As an example here. So basically, this is a common type of the metadata for bond, for example. As you can see that you have keys and point to value. So how the bond or the financial good is defined are based on the keys and the values they put in. So let's say I will have another example. So I can have another example. So I have here about another kind of financial product. So basically, I have another kind of financial product, and each of it has different kind of metadata. So that's basically how the metadata are used in the financial product. So if I'm working in financial companies, internally we have our own SQL or CSV file with all those metadata slots, what we call, and basically this is the whole CSV file with many parameters will define one object accordingly. And when we talk about this, ES20 typical ones don't have metadata structures. But for the 721, 155, and 3525, they all store metadata off-chain, and usually they will have a URL to direct the metadata to an address. And the 3475 is different because the metadata actually is being built on-chain, so it can be managed as something in the smart contract. So the smart contract can read them, decipher them, rewrite them, understand them much easily. And the third part is the token ID. So basically, if we are talking about ES20, don't have token ID, and 721, is there any problem with my connection? Hello?
I have a question.
Yes.
Do you think the last EIP is very base costing? Yeah.
Sorry, base.
Gas costs a lot of gas.
Yeah, I'll explain this maybe later. So if my connection is good, I will continue. Okay. And the token ID I mentioned here is about under one single contract, you have different defined object. So ES20 you don't have, and the 721 and 115 you have one dimension. So it's array from 0 to a given number. And both 525 and 3475, you can have limited list number, which is defined with a multi-dimensional structures. And finally, we have the batch transactions. So it's allow you to pack everything together. This is commonly used in traditional finance. When you have a lot of financial instrument, normally OTC tradable instrument, and you can pack them together to form what they call packages or what they call a batch. So basically with 155, you have rudimentary solutions to that. It's not designed for financial good, therefore it's not functional. And 3475, we use a tuple, customizable structures to do this kind of packaging. And in terms of storage, so basically when we talk about storage, we have a total balance, for example, it's like a storage inside of a smart contract. It's like a variable which can be read and write many times by the functions who had authorization. So both ES20, 721, 155, and actually our existing standards, their storage are defined with the code in the ERC structure itself. So basically, that's why it comes to the point of a physical keyboard. So when we talk about storage, let's consider all the keys are storage. So in their solutions, all the storage are defined, and you can't have any other storage without adding this to this physical keyboard. So basically, for us, the solution is we make this abstract and then make it like a virtual keyboard, and we can apply the changes when needed. Finally, it's the supply type, and we need to store three types of supply, and I'll explain why this is absolutely needed. And here we explain a little bit what the token standard, how the token standard can be used. So basically, it can be used for traditional financial. Yes.
What's the supply? Three supplies.
Supply is like so basically ERC20, you have a total supply, which is a given number from 0 to something. And with ERC721, you don't have supply because simply it's non-fungible. So 1.5.5 and 3.5.2.5, they are copying the same supply system as the total supply in ERC20. But when you talk about financial good, actually financial good have three let's say statuses. The first one, of course, it's what we call the active supply. So this means that the financial instruments are there, and the conditions on the financial instrument are not, let's say, fulfilled yet. So let's say if your simple cases, you have a bond, and the bond can be redeemed 3 days after. So the bond right now is active supply because the bond can be redeemed in the future, but it can't be redeemed now. It's one status. And second one is that after 3 days, I redeem my bond. So the bond, all the conditions on the bond, all the obligations are fulfilled. And I redeemed the instrument and get what is mentioned in the contract. So I get the money back, and the bond instrument will be destroyed. And this is called redeemed supply. It means that the contract, which was the object of the derivatives or bond, are being executed. And the third part is what we call burn supply. So basically, it means that the bond can be redeemed 3 days after, but for one reason or another, I choose to destroy my bond. So it's like if you have a physical paper bond and you choose to burn it, and in this case, this will be counted as burn supply. And I'll explain why. So when you put money into a pool, the total amount of money you put is a fixed number. And no matter when you burn it and how much bond you burn it, this number will not be changed. And when someone redeems, based on the total number of liquidity in the pool, the active supply on the market may not be the same. So basically, in order to know how much actually the bond is actually being issued, you need to have a total supply again. And this total supply is equals to the active supply, burn supply, and redeem supply added together. So that's why we need at least 3 statutes for obligation, because obligation has 3 statutes. So active one, redeemed one or being executed, and all the ones will never be executed again. So this is called burn one in our case. And here we mentioned about what the standard is built for. So basically, when we have the idea of building the solutions, we are discussing with the traditional institutions, the one being regulated the most, the banks, the brokers, financial players. And basically, this solution is developed for them in order for them to tokenize any kind of financial asset into what we call a token. It's called the tokenization in some case. And basically here, they have 3 use cases mentioned. So first, the traditional institutions is what the solutions are built for. Second one is a DeFi project. So basically, it's an updated way of manage a liquidity pool, for example. And we can convert a LP pool into what we call multi-layer pool. And I'll explain what this technology can bring benefits. And finally, we have other applications. So basically, when you talk about tokenization, actually, when you talk about an NFT, it can be used for gaming. But actually, if you are building metadata on-chain, it will be more efficient. And in terms of gas, you're not spending more gas than put the metadata on a blockchain. And I'll explain why. So this is basically I'll explain why how the gas fees are being saved. So basically here it's the structure, let's say the data structures of the ERC 475. And here you have the biggest, it's the smart contract level, and it contains everything. So we have two tiers of categories. The first is class categories, and we have nonce categories. So we can give an example, it's much easier to understand. So me and everyone in the meeting room, I presume you are human beings. So we're all Homo sapien, and we share, let's say, 99% of the DNA, which is the same, and around 1% of the DNA, which is not the same. So basically, we put 99% of the same DNA into the metadata storage of the class. And for example, my cat is a cat, and their DNA is much more different. So they have another class for cats, and under this cat, I say maybe 90% of the cats maybe all the cats have around 90% of DNA, which is the same. So they are being put into the class structure. So I'll explain why this can save gas fees. So basically, you and me, we are 99% something the same. And what we put under the class, which is in the nonce, which is a different part from you and me. So basically here, I write once with all the information about our shared common informations, common metadata. We put them in the class structures. And under the class structures, we have the nonce structures, which it's defining the specialities that we have. That I'm different from you because there are DNAs which are different. And here we have the structures which is like a box. So in Solidity, we can't put different type of variables into a same array. So basically, we have solutions to combine those on-chain metadata into the same structures. And I'll explain how this is done. So basically, the idea here is that each nonce under the same class, they share the same metadata that this nonce process, but the different part will be defined with the nonces. So any questions so far? Okay. So afterwards, I explain how this is done. Sorry, yeah.
Can you give more description about like that values dbit fix 60? What's
and
the...
I'll give more example here. So I just talk about the structure first, and then I'll give example a little bit later. So here, I'm talking about the class nonce and ID metadata structure. So how this is done in the, so basically, like I mentioned, the Solidity will not allow you to store different types of metadata in the same storage, which is impossible. And basically, we concluded the most likely there are 4 types of values which need to be stored. So we have a box, and this box is closed outside, so you don't know what is inside the box. But you know that in the box, you have a structure like you have 4 slots for one single box. And each slot is accordingly a type of the values that can be stored. So in the structure called values, which is the values stored in an array here, you have 4 slots, and in it you have string, integers, address, and bool. So the idea is that we are not putting all the values into an array, but we create the same type of box, and we put the box in the same array. So what will happen is that in the metadata, you can define, for example, the first values, value 0, and with the key 0, and it's a symbol, and it's the type of string. So basically, with this, the smart contract can know that how to read the information from which slot I got the values to read them. So I open the box, and I open the slot for string, and I get in the key 0, I got this. It's the symbol of this class, so it's value 0, and I got it from the string value. So in the cases of the class here, the values are being stored. It's like a mapping from a key to a value object, which is here. And in this value object, I had metadata which can define the types of storage, and I read the type of the storage, get the data out. So for the smart contract, when I read the data, actually it's consuming much less gas fee than read it from off-chain sources. Let's say if I'm using IPFS, for example, I need to visit the IPFS file, get the data out, and I need to use Bybit to convert the data into some other data from set Solidity can read. Basically, all those processes actually is consuming much more gas fees than the solutions we have right now, because it is regarded as a native on-chain storage. And basically, for the metadata, it's the same. So the metadata part, which is standardized, means that the metadata can be stored off-chain on IPFS file. And your metadata, you don't need to store them anywhere. You just put the values in the right slot. So let's say we define the class, the key 0 always be the symbol of this class. So basically, I don't need to put other information here because it's fixed. So it's like something you will not, well, it's like a constant. So basically, you don't need to put metadata on chain. You can put it off chain, and what you put on chain is simply the values, and it's not 4 values at one time. You're just giving the value that you want to store. In that case, it's consuming less gas fee than actually read values from the off-chain sources. For example, on IPFS. And when this, it's just a very early example of how the data are being displayed. So basically, in this example, we have 1, 2, 3, 4. We have 4. We have 4 metadata slots, let's say, and the first is symbol, so it's like 0. And in it, I put the values, which is the values from the first one, second one together. And we have a multi-call to allow the front end to get a range and fetch all the data together. So basically, when the data is displayed, the data is displayed in this way. And the problems with the existing NFT solutions are very simple. The metadata can only be displayed on a picture. So basically, I need to put all the things in the picture, and they call a dynamic picture with some information about if this is a coupon, if this is a bond, if this is financial goods. So basically, you can't like normal thing arrange all the data and see everything together and track all those metadata. So it's basically impossible for the financial use cases. So that's how the metadata are being stored. So in this example, we have the values. So in the slot in the values key 0, we have some values, and each values I read only the string of the values. Then I get a string of integers. And in this case, in the key 2, I have the type address. So I get an array of values, and I read only the address slot of the array of values. So I got a string of address. But in the terms of structures, when you fetch them together, it's one very long JSON file that can be transmitted through smart contract and to the front end, and then you render all the data to form them into some kind of display. So this is how the class and noun system and metadata are being stored on chain. So any questions so far? Okay. So afterwards, we're talking about something which is very, very important in the cases of traditional institutions. So when we talk about traditional institutions, big players, banks, governments, and them, there are one thing they care the most, which is KYC, know your customers. So they need to prevent who has access to use applications and who can't use it. For example, if you are money laundering, if you are providing financial services for terrorists, for people regarded as dictators, you will not be allowed to use certain kind of financial applications. And most of the time, when the Western governments, especially the states and the European Union, when they talk against the DeFi, it's because the KYC solutions are not there yet. And basically, it's a very big topic in a law that in Europe called MiCA, and in the States, there are SEC regulations. And basically, they're talking the same thing. DeFi protocols need to provide KYC verification process for their users, especially in the States and in European Union. Basically, in our solutions, we have another built-in solutions which called Society. So this is a KYC solutions allow you to store the DID certificates. Basically, the idea is that every time when someone wants to use the functions inside of your smart contract, you have a built-in modifier. And this modifier you can find here, ERC 5851. But this modifier actually can control the access of your certain functions to a certain group of person. On which group we are talking about? We are talking about a group of person who has already done some kind of DID or KYC verification process. And so it's not about the KYC. I'm not explaining more. The idea is that in the future, let's say 2 or 3 years, this will be 100% needed in all the DeFi transactions. So basically, you need to have this kind of built-in modifiers to verify the KYC information about one user to another. And even for the transfer function, it's like, I want to transfer my token to an address. This address in the future should be passing the KYC process. Otherwise, you can't transfer the tokens accordingly. And afterwards, another feature is the bank transaction. So in the case of financial good, it's normally we will pack different instruments into a package. So let's say I have a bond from this company, bond from that company, another instrument everywhere. I put them into a package and sell them on a secondary market. In our cases, we have a function specially designed for this case. And it allows you to pack a group of financial instrument into what we call transaction structures. And then you can put this new object packed on a secondary market to sell them and doing things. And sorry. This is type of supply, just mentioned about redeem supply, active supply, burn supply, where we need them. And this is the event. So basically, we are talking about ERC20. You need to add a specified token address to your wallet in order for your wallet to read the balance. But for our case, we have an index of all the transfer functions and all events. We capture all the events and convert the values into those events to convert them into some kind of dictionaries or index. And then we can know exactly what tokens in your wallet and to read their balance accordingly. And finally, we have some examples about how you define object. So we define a class as a type of the bond, and we define the nonce at different time periods. So let's say if I issue the bond today, it will be different from the bond I issue tomorrow. But 99% of the data which is in the class is the same. So the bond I issue today can be redeemed 10 days after. The bond I issue tomorrow will be redeemed 11 days after. So they should be the different object, but they share mostly the same metadata. So the shared metadata is put on the class, and the different part which is put on the nonce. And here is some use case with Commutator pool. So actually, we allow you to create a pool that you can hold all the tokens inside, and based on all the tokens, you put many kind of LP tokens based on the period you are choosing, the interest rate you are choosing, and many different kind of information you are choosing. So basically, it's using very simple solutions would create a virtual pair and allow you to reduce slippage by put all the liquidity into the simple So if you, let's say if you have only one pool in the whole market and with all token inside, this pool has zero slippage in any cases. And the benefits of it is that you can have a different tier of risk for the same pool. You can have most valuable asset and with less interest, and the less valuable asset with much more interest, both in the same pool. So this is likely to be a next step of the AMM solutions. And afterwards, I explain why we need the solutions come to Ethereum. So we mentioned some cases about creating Empire and AMM. So in the case of the APM solution like Uniswap or PancakeSwap, each time you create a pair, you pay the gas fees. But in these examples, you put all tokens in a single, let's say, a custodian contract. I don't need to pay gas fees. So we mentioned here the gas fee is reduced, adding liquidity function is reduced. And how the benefits about abstract storage, I just mentioned a bit before about how to have virtual keyboard to actually build everything with the same standard structures. And here it's we're talking about why to tokenize this, because actually all the NFT tokens and the ES20 tokens, they presume that they can tokenize financial good. But as someone work in the financial industry for some time, let's say, as a backend engineer, I know their token standard is not suitable for the most complicated financial good. Actually, you need to add a lot of things and change a lot of things. Like you are adding a lot of keys on the physical keyboard. Basically, it's not a good solution. And that's why we have a new solution which we call 3475. And there are other considerations that we were discussing, building the structures, but didn't apply them. It's basically to give a much wider range of adaptation possibilities to our token standard. And finally, you have some benchmarks about the gas fees for the solutions. We talk about gas consumption. Just talk about simple cases in AMM because we can have the benchmark to compare with. So for the swapping, Curve Finance and Uniswap V3, actually they are consuming relatively the same amount of gas fee. So it's a calculation from 10 transactions. So this is average of 10 transactions. And when we create pairs, actually you can see the difference. And Uniswap V3 is very, very expensive. For the Curve Finance, it's less expensive, but for multi-layer pool, actually it's as the same like a swapping because the data structure are virtual. You're just adding a new mapping into the mapping structures. And finally, when you're adding liquidity, it's the same. It's more gas efficient in these cases. And when you talk about tokenizations of real good financial assets, read the metadata option, convert them into on-chain information, and convert them back again to IPFS, which I can assure you is much more expensive than our solutions in terms of gas fee. And finally, we can have some examples and some discussions about the token standards. So for example, here, you have those metadata you need to put into the storage and you need to display them to demonstrate only one instrument. So this is done using metadata structures. And finally, we have a tool which is built-in wallets to help you let's say see your KYC information and see all your bond. So basically, we provide it's a white label solutions. And we provide solutions with the whole platform and we can adapt platform to your needs. And this is how we operate. And basically, this is about our solutions. And for more information about the demo of the applications and everything, you can visit our website at Decimal Labs or go to debond.com or visit us in our office in France, Paris. And or you can book a meeting anytime. And yeah, it's basically about the presentation and anything related to our tokenization solutions. Yeah, so I finished my presentation. So any question? Hello?
Hello.
Yeah, any questions?
Yeah. Any questions? I think our bodies may need more background. But I think it's very wonderful. Yeah, I will have a try later.
Yeah, I think the idea here is we are talking about what DeFi will be look like in 2 or 3 years. It's not standard for now, I presume, but the KYC solutions combined with on-chain metadata storage for the traditional financial instrument, I think it will be the cases for 2 or 3 years after. When the big players come into the pictures, they will bring their needs, and someone worked for their backend. I can know their needs is much more complex than what an NFT token or what a ERC20 token can carry. So that's basically why we design the solutions and how the solutions are being designed. It's with the feedbacks of those traditional institutions, and we ensure the KYC cases and the data structures are being 100% compliant with their need. So this is basically why we need why we build our solutions in the first place.
Yes. If there is no question, we can go to next session. Yeah, question and answer. Yeah. Hi, Yu, can you open the link and send in the chat window?
Yeah, of course.
Yeah, we have collect the 3 questions. Yeah.
I have some trouble opening it.
You have
okay, I think I get. Oh, yes. So difference from STO. Okay. So the STO tokens is using typical structure of ERC20 token. And when we talk about why STO is not successful, let's say, it's because regulation issues. So they have no common ground of regulation for the STO token, which means that there are no STO things is not continued. And also another factor very importantly about this is because the settlement are 100% centralized without any smart contract. Basically, centralized method. Why this centralized method? Because the metadata, again, they are being built off-chain. So basically for ERC20 smart contracts, almost impossible to manage the logics of the redemption and everything on-chain. So there are 2 major issues about the STO solutions. The first, like I mentioned, is the KYC, which is not considered, and in most of the legal background, it's not compliant. And second one is about the data structures, which is off-chain, and this lead to no smart contract-based settlement and lead to no smart contract-based management of the fund. So basically, it's a centralized way, and I think that obvious difference between our solutions and the existing STO solutions. So for example, if you are mentioning this token solutions 151400, actually they are using exactly the same structures like ERC20 and ERC721. So what they are doing is that they put all those additional informations into off-chain storage. So if I check, yes, yeah. If we check the solutions, as you can see that they try to be compliant, but how they are trying to be compliant is actually they have a master role, and the master is called operator role. So this operator role can actually manage the financial good for you. And here you can see that the metadata structures here, the events and everything, they are in the same structure. So basically you can adapt this to your need, and you have issue redeem and everything. It's like I mentioned, physical keyboard here, and therefore you can make and use this for securities, the same kind of securities where this is designed for. Or if you read a little bit about the comments, you can see that the most difficulty part for people to use this is the 2 issues. First one is the this is too centralized, and the metadata is the option, and second one is about KYC. And the KYC is actually much more important. It's very important cases in the business. So if I search, so if I search some keyword and MiCA regulation. Okay. Yeah. So I do suggest you to read those articles about the MiCA laws and about the SEC regulations. So you will realize that how important the KYC built-in KYC is in the token solutions. So I do urge you to read those articles in order to understand better the KYC part.
Can you send to the chat window? Yeah.
Yes, you can. But actually, you can find this kind of articles with some keyword like MiCA regulation.
Okay.
Most of them they are already passed, and they will come into force before the year 2026. So basically, after the period of grace, which means that the law are issued but without putting in practice. After this period, if you are providing DeFi solutions, DeFi services to a citizen based in EU or based in the States, it's like considered as providing illegal financial services. So it will be very badly regarded by the government. And afterwards, how fairly evaluate the values of it as a collectible asset. How to fairly evaluate. So basically, in our cases, if we are talking about the valuations and build liquidity assets, consider them as the same questions. We have a way which is more based on the let's say the market expectation of the value of NFT, and in terms of the creating liquidity for the NFT, to talk about NFTFi. So we have mentioned two things. One is the pricing the NFT, and the second one is make the NFT more liquidable, so make them more tradable as a financial assets. So how this is done in our case? So basically, I can show you some materials. I can have some I can show you. Okay. So I can show you some Figma file. So the idea is that we have a secondary market, and we have a Dutch auction method, allows you to put all the good into the same format of the transactions. So let me see how to get connected. So basically, we are using a Dutch auction, and we convert the NFT, put them into a pool, and have different kinds of tokens based on the values of the types of the NFT. Actually, we are like it's an auction in a real market, and we are using Dutch method, which starts from the highest price of the last auction to a lowest price you set. And basically, when the time passes by, the price will become much lower and lower until someone takes the bid. So in the example here, so this is a common Dutch auction method. When we have the tokens compiled together, we sell it on a secondary market and use Dutch auction. The first start with the initial, let's say the highest last price of the NFT, let's say, and the package of the NFT, let's say, and then we have Dutch auction to reduce the price accordingly. So basically, we can have a package. In the package, we can have 10 NFTs at the same time. So when you purchase a part of the share of the package of the NFT. So basically, it's how our solutions can be used for the NFT pricing. But again, it's not related to the ERC 3475. It's related to the bond solutions that you can find in you can find documentation of it in debond protocol. Yes, you can find it here. I think. Yeah, you can find how the auctions are being performed, and you can find more information. So if you are interested in the auction mechanism, you can check this link here. I will send it again. Yeah, you can check the link for further information. Yeah, so I think it's all good for me. Do you have any questions?